So primitive types are the data type which stores a single value. So const string equal to hello. This is a string. I have number. Const number equal to 10. This is a number. Const is logged in. For this is boolean. So all of these stores a single value. These are known as primitive types. And when you have object or array, they store multiple values. So they are known as reference types. So you have multiple values storing T30. So this is the reference type, and this is obj equal to user name Mike, age 30. So these are reference types. So what we need to remember is that whenever you copy anything, so let's say when I do, this is a string, and when I say copy string equal to, I will assign string and I will print original string and copy string, and I will also check for equal string equal to copy string. So you can see string is hello, copy string is hello, and both are equal. Why? Because they are copied by their value. So they are primitive type. So when I say copy string equal to string, what happens is this string, whatever value you have, will be copied here. So the values are exactly same. So whenever you are using triple equal to, these are primitive types. So it's compare those values. So both of them are having same value. So they are equal. Same is with the number also. Number, or if you are checking for boolean value. So both of them, all these three things will be checked by their value. So when you assign any number or string to another string, the value will be copied. So they will always be equal. So whenever you are comparing with triple equal to, they will be equal. Here I can say copied is locked in equal to is locked in. I will bring this is locked in, copied is locked in. Then I will say equal is locked in is equal to copied is locked in. So they both will be equal. You can see both are same and equal is also same. So when they are compared by the actual value. Now in case of array, if I say copy equal to array, and if I print array copy here equal copy. So you can see here you are having array and copy. So what happens is in this case they are both equal, because when you assign copy equal to array, the reference or address will be copied in case of reference type. So what happens is if I change, let's say in array copy of 1 equal to let's say 100 or 1000. Now what is copy and what is array? What will come? So even though you are changing copy only, so I am changing copy of 1. So the first element I am changing, but this also changes the original array. So if I check here, you can see both are same. So even though you are just changing copy, whenever you change anything, it's the original array change. Why this happens? So let me show you. Array equal to 10, 20, 30. So when this array is stored, so how reference types are stored in the memory. So how they are stored in the memory, that is computer memory, not in browser memory. So here, this is the array. Did not quote 10, 20. So this is your original array that you have, and how that is stored is this is the actual array. So when the array is created in the memory, array variable does not contain this array. What array contains? It contains the memory address where the actual array is stored. So the actual array is stored somewhere else in the memory. So that memory is having address, suppose 10,000. So when I say array equal to this, array contains reference of that, so memory address. So this array variable contains the memory address of that location where the actual array is stored. So ARR, this variable stores the memory address or reference. It just stores the reference of this, and this will just point to this memory address. So when I say array equal to something, array contains, does not contain the actual array, it contains a reference of that memory location. And when I say copy equal to array, so you create, let me move this above. So you create a copy variable, and now it stores the same reference. So here it will again have 10,000, and it, so both of these array and copy, when I say copy equal to array, it's not the value copied. So exactly values are not copied. What it does, it just refers to the location where is actual array stored. So both are referring to the same location. When I say, if I say array equal to 100, not array equal to array of 2 equal to 1000. Now what is happening is, I can do this after all. When I say copy of 1 or array of 2, both are changing the exact same location data. So both are changing only this area. So when I say copy equal to or array equal to, both are referring to the same memory location, and when you are using any of them, you are directly changing the original location. You are not changing their copies. So both of them will be referring to the same location. So here you will see both having same data. So both are having, I have used 10, let's use 100. So you can see both of them are changed because both are referring to the same memory location. So you need to remember how they are stored. So when you are storing, assigning any value as a reference like a array or object, you need to remember that that refers to that particular location. They are not copied by value. They are copied by reference. So the reference or memory address is copied. So when I say const obj1 equal to obj, now this object also works the same. So this is obj1. So this is obj equal to name Mike, age 30. This is the object. And when I say this, what it means? It means this is the obj variable, and it will store that object, but that object will be stored somewhere in the memory. So this object name Mike, age 30. This is stored somewhere in the memory, and it has suppose address of memory address can be anything. This 40,000 is the address of that particular memory location. So now this obj will store that address 40,000. So when I say obj equal to something object, that does not mean obj contains that object. Obj just contains a reference of that particular object, and that object is stored somewhere in the memory, and this will refer to that particular location. So when I say obj1 equal to obj, now you have another variable obj1. It will have, so when I say that obj1 equal to obj, it will store the same memory address, and that means it will point to the same address. So now when I say obj1 dot name equal to Mike, obj1, now if I say obj dot age equal to 80, and if I print obj1 obj equal, you can see both are same because both are changed. So when I say obj1 dot name, and I'm changing it to, let's say, Jerry, so both are changed, and age is changed to 80. So at both the places, so it's just the same place, but they are just referring to the same memory location. So when I say obj1 equal to obj, that means that object is not copied. So it does not mean like this. It means you are just started pointing to the same memory location. So this is the difference between array, the primitive types and reference type. So when I say primitive types assigned to some variable, it means that value will be copied as it is. So when I say const array equal to 1020, when I say array1 equal to 1020, so what will come? Array equal to array1 is equal, so what will come as a result? It will give us false. Array has already been declared. Oh, we are already, so let's say number 1. They will come as false. You can see you get false. Why? 10, 20. And this is at the memory location of, let's say, make this bigger, 40,000. So number one contains is 40,000. And when I say number two equal to this, number two equal to this, 10, 20. Number two, so 50,000. So now this number one will point to this number two will point to this. So when I say array equal to something, when I declare that directly, that means I am creating a new memory location. I am creating an array and storing in new location. So now this is in 40,000 location, this number two is in 50,000 location, and this contains those memory location. So these are exactly different addresses, so they will never become same. So it will always be false. But when I say number 3 equal to number 1, what it will become? So now this number 3. Now when I say number 3 equal to number 1, that means number 3 now will refer to this memory location, and it will have address of 40,000. So these are reference types. Array and objects are reference types. So if I say is equal 1, number 3 is equal to number 1. So I am assigning number 3 equal to number 1. So now both are number 3 and number 1 are referring to the same location. You can see number 1 is referring here. Number 3 is also referring here. So they are both equal. So when you compare, you can see you get true as a result. So reference types, these are array and objects are reference types. They are not primitive types. So when you are assigning primitive type, so when you create another variable, value will be copied as it is and not the reference of that. And when you assign a what is known as reference type, it will just store that memory location address or reference of the actual memory where that array or object is stored. So when you are declaring two different arrays, they are never equal. So this is array 1. When I say array 1 equal to this, so when you create a new array, a new memory location will be allocated. This is also another array which has new memory location. So when you compare them, they will never be equal because they are different references or different memory addresses there. So you can see this is coming as false, because when you are declaring different array, different memory location is allocated to them. So whenever you compare two objects or array, they will always be false. So whenever you are comparing with triple equal to, you will always get false because they are never equal. So even if this is one object, I create another object obj1. So even though the content is same, obj2. So even though the content is same, when you compare, you will never get this equal. So obj2, obj2 equal obj. You can see you get false. So only when you are assigning, so array and objects are reference types. So when you assign like this, what it happens is it just refers to the original object.
Then if I want to compare the two array,
you need to manually compare each number one by one
by using that loop only.
Yes, you can use that, or you can use Lodash. There are methods. Lodash is a very popular library. It's a utility library, so you can use. There are a lot of methods here in this particular library. So you can is equal. It's a very fast also. So you can use is equal method. So is equal, you can compare objects, array, or whatever string number. You can see here compare array buffer, date, map, number, anything you can compare using is equal method. So let's say So to use this, you just need to install Lodash, or you can use Lodash CDN. You can just include this Lodash library and you will be able to execute those functions. So now this is already lodash.com, so it has already that support of all the methods. So what you can do is I can copy this array, and this also. So underscore. So whenever you are using method, you can see underscore dot. So underscore is for Lodash is equal, and you can compare array with array1. You can see you get true because they are same. So even though references are different, they are same. In this case, the actual values are different. So that's why you get false as the result. So when you want to compare two arrays, you need to manually compare each number by number or value by value, whatever object is there. Otherwise, you can use Lodash method, so which actually compares the data stored in that array, not the reference. So when you use triple equal to, it compare the reference or address of that memory location. So both are having the different memory location. So this and this are allocated different addresses. But when I say copy equal to array, now it just refers to the original array. So it's not actual copy, it just refers to the original array. So original array is stored at memory location, suppose 4000. So here, so they are totally different. So this array refers to this, and this array refers to this. So when I say now, instead of this above, when I say copy equal to array, now what happens is, when I say like this, now copy is a new variable. Now it will refer to the array. So now it will have memory address 40,000. Now it will start referring to the original array. So it does not create a new array. So new memory location, memory will not be allocated for that, for copy variable, because you are assigning an array which is a reference type. So when you assign something which is a reference type, array or object, you will just refers to that particular variable or particular address, particular reference. So now copy and ARR both are same because they are having same memory address, 40,000. So they are referring to the same memory address. So that's why when I say, where we compare here, array and array1, they are different. But when I say array equal to copy, you will get exact same result. You can see it's coming as true. So that's how they are stored in the memory. So you need to understand this. So whenever you are assigning any reference type to a variable, it will start referring to the same address allocated. So it will not create a new memory location. So this, when you define different, so when I directly define different array, now even though it's empty, a new memory location will be allocated for this. So now array and copy are not same, they are different. So you can see you get false, because even though it's empty, that is an array. So a new memory location will be allocated for this. Let's say we have const user equal to name, Mike, age 30, location city, New York State. Now this is the user. Now when I say copy equal to user, it will not be copy, it will copy. This user is a object. So objects are of reference type. So when you assign a object or array to any variable, it will start referring to the original user. So where the memory is allocated for this object. So now both are equal. So this is not a copy. So when I say compare, copy is equal to user, they will be true because they are referring to the same memory location. Copy one. You can see you get true as the result because they are referring to the same memory location. So how can you copy this object? So I want to modify. So whenever you want to do some operation, never modify the original array or original object, because you will lose the value and later you cannot get that original value. So whenever you do some operation, do on the copy of that object. So how can you create copy of that object? So you can create a new object. So whenever you create a new object, syntax, a new memory location will be allocated. So now I can copy whatever I have. So I can spread out the user object. Now what it will do, so if I just print this copy1 equal to user, you get what we are doing, compare. So compare is false because now this is a separate memory location allocated and this has a separate memory location because you have created a new object. So what is happening, you are copying all these properties. So you are using spread operator, so all of these will be spread out in a new object, but only the first level of the properties are spread out. So name and age will be spread out, and location, so location, what happens is location, and this is refers to the object. Now this object, as I said, whenever you create a new object, a new memory location is created. So this, what is happening is this will be copied as it is. So a new memory location will not be allocated for this. So whenever you create a new object, here location is a new object, so new memory location will be allocated for that. So now name is a Mike, age is whatever we have mentioned, and location does not contain the actual object. Location contains, because location is an object, so it contains memory address or reference of the object where that particular object is stored. So this is the object which is stored somewhere else and it contains 60,000. Now copy1, what you are doing, copy1, you are spreading out all the properties. So when you do spread operator, it does shallow copy. So only these particular properties will be copied. Now copy1 will have another memory location with these particular object properties. So this, whenever you are doing spread operator, it just copies the memory reference. So it just contains that particular address. So this will have 70,000. Now it will have 70,000 address. So only the first level, name and age will be copied as it is. For location, as it's an object, only the reference will be copied. So it will still refer to the original location object. So this is the original location object. This copy1 still refer. So what happens is, now if I do this and if I try to change, so let's say first print user, and now I will change here, I change copy1 dot location dot city. Now here I will change copy1. So if, yeah, as you can see, I have changed only the copy1 location dot city, but it changes the original user's location. Now I am printing user and copy1. So you can see this is the user, its city is changed to Albany. For this also it's changed to Albany. So whenever you are using spread operator, it only does shallow copy, which is means only the first level properties are copied. So this is the first level, and this contains an object. So object or array, if you have, their memory address will be copied. So location of this user copy1 will still refers to the original location. It will not be new location. So when I create new object, it's a different object. But in this case, when you are using spread operator, it does not create different object. It will just copy the reference of that. So copy1 location, it still refers to the original user location. So that's why you see the both of these are changed. So even if I change now location, this is user.location. When I say this is the last statement executed, now I'm changing user.location. So this is the user.location. Now copy1 and user will have the same London location. You can see. So when you are using spread operator, you need to remember this is shallow copy and not deep copy. So if you want to deep copy, like, so when I compare this user and copy1, you will always get different objects. So you get false because they are not different, but the values are actually not copied. They are copied as a shallow copy. So it's not, location still refers to the original object. So now I don't want to refer to the original object, because whenever you are want to change something, it's good to not change the original object or original array. Always create copy of that. So to create a copy, what you can do is spread operator does not work, because if you have nested property, it will copy that particular location as it is. So what you can do is you can use this deep clone method, cloneDeep method they have, or you can, if this object is not a bigger object, so what you can do is you can copy that manually. So now I will create a new location object and I will spread out all the properties. So it has two properties. So I will spread out location user dot location as it is. So now when you compare, they are still false because they are different, and this is not exact copy. So copy one and user both are now different objects. So when I say copy one dot location dot city, it is just this object. Now location, this location does not refer to this. So when I change this, let me comment this out. So when I say copy one dot location dot city, only this particular object is changed. Then user object will remain as it. So for user, you will say city and state New York. You can see its city and state is not changed. Only for copy one it's changed. So this is known as a deep copy. So you manually copy at each level, or you can use that cloneDeep method. So I can have this. So let me use load-cd and we don't have to go there. Now we have included lodash before our file. So now we can use lodash methods. So let me try by printing underscore to see if, yeah, it's there. So now what I can do is I can do cloneDeep. What are the deep clone or cloneDeep? CloneDeep. Const copy clone underscore dot clone deep. It does deep level copy. So I will create user object. Not here. You can see you get the exact copy of this particular user. So New York and state, and they are not equal. So when you compare them, they are having different memory address. So when I compare clone with user, you will get false because they are different. So cloneDeep creates a copy of that object, and it does not do the shallow copy. It does deep copy. This is known as deep copy. So you are having separate memory address, or everything is separate. You are not referring to the original object. So cloneDeep method, you can use lodash method to create a deep copy, not the shallow copy. So there is this is using spread operator is a newer way, ES6 way. Before that, we were using object.assign method. So const copy clone one. So object.assign method, you can pass multiple values. You can see target and so. So here is the original target you want to pass, and you can pass multiple values. So let's say name Mike, age 40, clone one. So you can see now we have a new object with name and age property. So this first parameter is important. So if you don't pass this parameter, then the clone one, let me show you, const user one. Now what I'm doing, object.assign first parameter is the user one, and then I am adding age of 50. So as I said, when you use spread operator, if you already have a same property, this property already exists, it will be overridden. So now you have name Mike and age 50. But this, when you don't pass this user one as the object, it changes the original object. So if I see this user one, you can see both of them are same. So this, if you see as assign method, this is the target. First is the target element. So it is the object to which these values will be copied. So if I have multiple values, I can do that also, and they will be copied or assigned to this user one. So if you don't want to modify the user one or original object, pass a new object. So when you create a new object, new memory location will be created. Now this result, so when you don't do this user one will have that modification, and that will be returned in clone one. So the reference of that will have, clone one will contain reference of user one. But when I say empty object, now we have another object, a new object to which these properties will be added. So you can see now what I'm printing, clone one, age 50 is printed. So if I add age 60 or salary 50,000, those will be added here, age 60 and salary. So this is same as using spread operator, but spread operator is better than this. So if I want to do same thing using spread, what I can do is I can have this entire new object, then I will spread out user one properties, then I will add age 50 again. If I want to add age 60 and salary 50,000. Now this is a newer way, ES6 way. So you spread out these properties and add those properties. Instead of this was the original way. So you provide each object separately and they will be combined into the one which you have passed as the first parameter. So this is the new parameter. So all these objects will be combined, merged into this particular target object. So if you don't pass this, so this will become, user one will become target object. Now user one will have all these properties merged. So now both are same, clone one and user one are same because you have modified user one. So always whenever you are using object.assign, make sure you are passing different object. So it will not override or it will not change the original user one. Now you can see both are different. So you have not changed user one. User one still remains as it is, name and my age. Object.assign and spread operator both does shallow copy. They don't do the deep copy. So even though you are referring to user one, so here you have not added location here. So user one. So now if I say clone one, so clone one contains user one property. Instead of user one, if I do user, so what contains in user contains location. So now this clone one will have this location object also, but it also does the shallow copy. It's not deep copy. So when I say clone one dot location dot state, you can see state is changed to Albany. Now if I print this user, you can see both of these are changed. So user one and clone one. So both are referring to the same location. So either you use spread operator or use object.assign, both are doing shallow clone. They are shallow copy. They are not doing deep copy. So if you want to do deep copy, you can use this manual spreading. So you need to spread each property manually, or you can use cloneDeep. This is deep copy. This is shallow copy. Not this one, this entire thing. So here this is not shallow copy because you are doing manual thing. But if I don't add this, then it will become a shallow copy because it will be copied. Only the first level properties are copied as it is. So now this is also shallow copy. So this does the cloneDeep clone. You can manually do, or there is also structured clone. So JavaScript has added structured clone. So this is not too much supported. It's a recent addition that also does the deep clone method. So you can use structured clone method. So structured clone. Now let's say user structured and user. Now you can see both of them are same, but they are cloned now. So it's a deep copy. So when I say structured dot location dot city, let me change it to London. Now you can see structured has city of London and user has city of New York because user contains the original New York city. So this is the user whose city is already New York. So it is not changed. Only when I say structure.location.city equal to London, only the structured city will be changed. It will not change the user city because this is doing deep copy. So this structure will have separate location. So it's not reference. So it not refers to the original location. So this is known as the deep copy. So structured clone you can use, but that is not well supported. So if you see, can I use? It's only 90% support. So not all browsers supports it, but it's a better way to use structured clone. Structured clone. So you can see structuredClone API. This is the browser, Chrome browser, supported February 1 to 30 May. And you can see the total support. It's supported by 90% of browser. It's not 100% support. So Firefox, till these versions up to 93, they don't support it. So this is a very nice website. Can I use? You can check any CSS property or anything if it is supported or not. So if I say gap property, CSS gap property, whether it is supported or not, you can see it's 95% supported. Or if you want to use any flex property, display flex, you can see it's supported globally with 98%. So we always use CSS display flex property. So this here you can use, check what it does and how much support is there for any API. If you want to use, you can check it here. caniuse.com. So this is deep copy. So you can also do deep copy using JSON.stringify. JSON.stringify user. So this is, you can see it's as it is, but it's now stringified. Now, if you want to get that value back, convert it. So when you use JSON.stringify, it converts into string. So if you want to get back the original object, you can use JSON.parse deep copy. Parsed. Now you can see you get this result back. The original object you get back. Now when I say parse, not parse, deep copy, location.city equal to USA. Now user contains New York property. So, and this I am changing from deep copy only. So no, only the deep copy city will be changed to USA. Cannot set properties of undefined. Oh, this is not parse. Parse, we should do this here because this deep copy is a string. Now this is actual object. So you can see user state is Albania, what I'm changing city. City is still New York. For parsed, city is changed to USA. So only the parsed, whatever you have deep copied, that will have the city change. So they are both different, they are not same. So this is also deep copy. So deep copy means everything is different, even objects are different. But this stringify method you should not use because it's a slower, and it if you have some what you can say functions or date, they will be skipped. So you will not get correct data back if you have some functions. So you might have functions here. So this object might contain display function. So if you stringify this object, then you will lose this context and everything from this display object. So you will not get that original object back. So if I add display here, function, display function, here I have, yes. So this is the user object. Now if I see here, display function. Oh, structured clone also does not work with functions. So let me comment this out. So you can see original contains display function, but the parsed one does not have functions. So they are skipped when you are using JSON.stringify. So you should not use JSON.stringify. Structured clone also has the same issue. The functions are also skipped, but that is better than using JSON.stringify because it's very slow. JSON.stringify is slower. So the great way of doing deep copy is using cloneDeep. So this is a popular method. So if you don't have any large object, you can do it manually, which is better. But if you have a lot of properties, then it's better to go with cloneDeep method of Lodash. That is a lot faster and it works really well. So these are the different ways you can use what you can say shallow copy and deep copy. And this is how you need to remember whenever you create new object, new memory location will be allocated. So when I create this object, new memory location is created. I have some, let's say I have user object, user array. Let's say this is object numbers. When I say numbers 10, 20 person. So this is an object and this contains a numbers property and I am assigning a new array. So when you create a new array syntax, its new memory location is allocated. So numbers does not contain the actual array. It contains a reference or address of that array where the actual array is stored. So this will have a separate memory location. So when you create something, it will have separate memory location. So when you declare array, that is a separate. So when you compare array or object, you will always get false as the result when they are separate. So I have this AR1, 10, 20, as I say, I think I have shown you. So when you are allocating different array, they are always different. So when I say AR1 equal to AR2, you get false because they are not same. Because AR1 contains the memory reference, memory location or reference of this particular array. And if I do USOB1 name Mike OB2, so even though content is same, they are different. So you get false because they are different. But if I say OB3 equal to OB1 or OB2, and if I compare this OB3 with, now OB3 refers to the OB2. So when I compare them, OB3 and OB, this is not OB2, it's OB2. You will get true as the result because OB3 refers to OB2, and this is the actual object which is stored in the memory. So OB2 contains memory location of memory address of this particular object, and OB3 also contains that memory location of that particular, the same object. Now this OB3
is the solo copy only, right?
No, this is not copy. This is you are just referring.
Okay. Okay.
Copy means you create a new object and you spread out those properties. That is copy. So this is not a copy. This is just referring to the same location. So OB3 just refers to this OB2. So now OB3 equal to OB2 will return true, but this will be false. This will be OB1 because OB1 and OB2 are different objects. So they are stored separately in memory. You can see OB1 is true. Now, if I compare this OB3 with OB1, what would you get? So OB3 refers to OB2 and OB1 refers to another object. So both are different. So this will return false. So when you compare objects and array, separate objects and array, they are always different. So when I compare user one, so user dot location, if I compare with what we have, let's create location here. When I compare with OB2 dot location, they are totally different. So this is a string. Let me add city. This is the object now. So when you are comparing with string, they will be equal because the value is same. So if you are comparing with this, let's say I am comparing New York, and this also has location New York. So both are same. So when you compare with triple equal to, you will get true as the result. So this is user dot location. No, this is not user. It should be OB1. OB1 dot location, and I'm comparing OB2 dot location. So these are string. These are not reference types. So these are primitive type. Primitive types are not referred by the address or memory location. So they are compared with the actual value they are storing. So you get true because they are true. So even if I add Boolean values here, false, false, they will be compared because they are compared by value, not by reference. So you will get true. But when they are object, so when you create a new object symbol, it's a new memory location. So when I say city equal to New York, and this will have city New York only. So even though they are having same value, they are not same because this is on separate memory location. This is stored on separate memory location. So you will get false as the result. So you need to remember that when objects and arrays are compared, they are always false. So these are different things. But when you are assigning to the same memory location, referring to the same object, then at that time they will be equal. So OB3 is same as OB2. So when I compare OB3 with OB2, they are equal. So you get true. So OB2 is true. So any question in this? This is very important. So when you are using React, you have a state. If state is larger, it contains a lot of data. So previously with class components, this cloneDeep was used a lot of time. But in when you are using functional component with hooks, it's not used much. But still, if you have some state which is storing some large object, in that case, you should not change the original state whenever you want to manipulate that state. So you always first need to create a copy of that and then update that particular state. So you always use cloneDeep method for doing that. So it's always good to not change the original object. If you want to change something, create copy of that and then change it. So that's always better. So you will have original value also. If you need sometimes later, you can refer to that. If you directly change on later, you don't have access to the original content. So that's why it's always better to not mutate the data. So that is known as mutation. Don't mutate the object or array. So keep it same as it is. If you want to change something, create a new object or array, like a copy of that, but don't use spread operator. Spread operator does shallow copy. And object dot assign, which was the old way, ES5 way of creating copy, that is also shallow copy. So if you want to do deep copy, if the object is smaller, you can do manual at one level. So if here I have name property, another object. So let's say name. Hello, I want to copy here, deep copy. So this is deep copy. But now in the location, I'm spreading out these properties. So this now name, this name location dot name will refer to this particular. It will not be deep copy. So if I want deep copy, I will add that name property. So location contains city state name. City state will be copied. They are separate because they are strings. But this name is an object. So they will not be created again. So it will just, this name will still refers to the original name object. So to avoid that, you can create a new object and you spread out all the properties. So if you have multiple properties, that will be better to use spread operator. So what I can do is I can do user.location.name. So now you have another object. So this is an entirely new object. So it's not a copy of that. So this name will not refer to this. It's a separate object. So that is known as a deep copy. So that's it. Any question?